All right, everyone, it's noon, so it's time for us to get started. Welcome, everyone, to NodeSchool San Francisco Online Edition. This is our focus session for July of 2020, and I don't want to overhype it, but I'm pretty sure and pretty confident that this is going to be our best focus session of July 2020. It's also the only one, but don't let that fact distract you because it's going to be pretty good. So what you're seeing now on your screens is roughly our agenda for today. It's actually a couple hours later, I just noticed. But intros is what we're doing right now, which is pretty meta. And in a few minutes, we're going to kickstart our session. And right after that, we'll have a few minutes for Q&A. So if you have any questions during the session, you can drop them in the chat. We'll do our best to get to those questions during the presentation. But if not, afterwards, both of our speakers are going to be spending a few minutes and answering anything that you may have in mind. So if this is your first time joining us, welcome. First of all, thank you for coming. Most people never actually return, so we hope that you have a good time today and you enjoy yourselves. If this is your first time joining us, let me fill you in on what exactly NodeSchool is. So the definition that we like is that NodeSchool is an open source project that is run by volunteers with a specific goal in mind, which is help you to learn Node and JavaScript. And we do that by creating programming content and by hosting community learning events such as these ones and our usual in-person events. The people that you see on your screens are the organizers of this community. They're sorted from left to right, from like best Thomas to like average Fernando. We're your hosts, so if you need to get in touch with us, you can reach out to us on Twitter or any of those handles or in the information that I'm going to give you later as well. Sadly, due to the situation that we're all living right now, we're not doing in-person events for the foreseeable future, but we're trying our best to find ways so that we can stay connected and share some content and things with you. And most of all, have a good time. We really miss you all, and we hope that you're staying safe, and we hope to see you all soon. As our normal events, we do have a code of conduct for this one. The real short version is that we're trying to create a harassment-free community, and we want everyone to feel welcome and a part of this. So we ask you to please be kind to each other. If you want to read the full version of our code of conduct, you can go to our website, which is nodeschool.io/San Francisco. Even though we're not at our physical venue at the moment, we do have some housekeeping rules for today. So please, if you're in Zoom with us, please mute yourself. If you're in Zoom or YouTube, drop your questions in the chat and we'll do our best to get to them. Most importantly, remember to wash your hands and wear a mask wherever you go. Help keep people safe. And snacks and drinks, unlike our events, we don't have any today, but the good news is that you can go to your own kitchen and get as many as you want. And they're probably going to be your favorite, right? So that's pretty good. All right. And pictures or like screenshots, as we like to say, take as many as you want. They're completely free. Tell your friends and share in social media. If you're sharing, though, keep in mind to tag us on Twitter at NodeSchoolSF and use any of the hashtags NodeSchool or hashtag SF, or if you're feeling really well today, hashtag NodeSchoolSF. Anything that you tweet at us, we will retweet you and make you internet famous to our 82 followers. So yeah, that's pretty good. If you want to get in touch with us, want to give a session, or have any feedback about this event, you can shoot us an email at nodeschoolsf@gmail.com, or you can slide into our Twitter DMs, which in fact are very much open. And now the moment that you're all here for our focus session. Our guest speaker today, Samarth Gulati, is one of our OG mentors from back in like, I want to say 2016, 2017, maybe before. I don't know, 1994, who knows, right? And currently works as an independent UX consultant. Samarth will also be joined by Praveen, who will be assisting with any and all questions that you may have. So feel free to drop them in the chat, both in YouTube and here on Zoom. Thank you both, Samarth and Praveen, for being with us today. We're really looking forward to see your session and learn from you. So now I'm going to shut the hell up and stop sharing. And Samarth, the floor is completely yours.
Thanks, Fernando, for the awesome introduction. I don't know, you're getting better like from last time we met. So it's just like, I'm pretty sure you've done a few of these now. So yeah, just to make sure, can you guys see my screen?
Yes.
So yeah, this is just like a quick rundown of face painting in JS. So just to give introductions. We'll start with Praveen over here. Oops. Yeah.
Okay, hi everyone. So I am Praveen. I am a interaction designer and a freelance consultant as a UX educator. So I generally dabble with new media works. So I make filters. Sometimes I work with data visualizations, and right now I am also exploring augmented reality. So it was fun working with Samarth on this project. So I think Samarth will continue.
Yeah. To introduce myself, I come with a background in UI development. I was working with Adobe in their stock, like primarily for the stock product, doing a lot of these prototypes in AI machine learning and all the advances they had for image analysis. Uh, it's been like almost a year. I've left Adobe and I'm working in India as an independent consultant now, doing all sorts of trippy optical illusions through code. Just that because all these prototypes I was building were using Canvas and SVG, and I just found like there is so much more artistic use to it than building like these rectangles and applications for people to click on. So that's what I've been up to these days. So earlier this year, I met up with Praveen for PCD Delhi. PCD is Processing Community Day. It's a great event for creative coders to get started in creative coding and meet other artists who've been exploring the new media side of things. What I've been trying to do is collaborate with artists and figure out if I can apply for like museums, open calls, and see where I can get up like some installations of some of the work I've done. So just happened so like when we met up, there was this open call by Science Gallery with the theme of contagion, something related to the current COVID situation as well. So what we wanted to do was emphasize on the fact about that all these communications we are having these days is very much over text and not so much in the face-to-face realm. And we're losing a lot of these nonverbal cues in those conversations. And so just to highlight those, we wanted to have a face-to-face kind of conversation, but with anonymity intact across two random people over the internet. With the voice muted. We thought like, okay, Animoji is like a really good contender for that, but it was very platform dependent. So that's where like TensorFlow came in. They recently released their face mesh model, which basically allows you to have a normal two-dimensional camera, infer the face data from it, and create a mesh out of it. As you can see over here, it's like very responsive. It works really well even on like low-end smartphones, and all the computation is happening locally on your phone. So that was basically what got us excited. Coincidentally enough, like I was working in WebGL or trying to get my hands into it. And there is this amazing tutorial series by WebGL Fundamentals. And you can go on there and go through the nitty-gritties of how to get started in WebGL. Some of it is what we're going to cover today, but not to most of it because it does go into like, it's very verbose. And we're just going to use a library for the most of the things, which is ThreeJS. So as we got started into it, we took the prediction from TensorFlow and put that out in top of the face camera rendering and itself put it out in WebGL as points. And now once you have the points, the TensorFlow model also provides you the triangulation, how you can connect those points together to form a polygon. And now you basically get a full face mask kind of a thing. Again, all these renderings are happening on the fly through the predictions that the model is spinning out. And then as you go further into it, you can put colors and then even through UV mapping, put some texture onto it. Now, the problem is those projections for those textures are spherical, so it might get some distortion. So if you draw a circle on the texture, you will basically end up as an oval because it will stretch and warp the texture itself. So what we ended up doing was make our own custom UV map. So what you see on the left is the one which was provided by Google. But on the right, what we did was just do like a head-on front view projection of it. So if you've been working in Blender, you might see this front project from view for UV mapping. And what this allows us to do is like if you draw a circle on it, it will come up as a circle on the 3D mesh itself as well. Now, what this basically makes us do is send this mesh, which we have, to artists and ask them to just paint on it. And once we have like a creation such as this, Now it renders perfectly well onto my face with the eyes and nose and everything matching pixel to pixel. Now, the problem with this whole WebGL contraption, which we had built for us, was that it was too verbose. To make any amends and add more features was really hard. And that's where ThreeJS came in. And ThreeJS just simplifies all these things for us and adds the extra layer of having some anti-aliasing and alpha values, which allowed for all the other explorations I'm going to share now. Now, once we had that, what we tried to do was, okay, we can possibly do face masks, and we went into all the cultural repository of India, where we have each region in itself has its own history, and you can pick from their history around different cultural representation of faces and put those in a 3D AR filter like through the AR face mesh. Not just related to culture, we can also use what we are currently facing these days, protective face mask, and use those as a try-on feature directly in mobile AR. Now, with that, we can also allow you to have a canvas in which you can put some text, emoji, or whatever you want as a message and try that itself as well before you want to send it off to, say, the vendor to print it out. And not limiting yourself to just a texture of it, we can also put in 3D objects and track those through its position with like even a nose pointer and then see how it tracks and works well. So you can try spectacles, other kind of facial accessories, and see how they look on your face. Lastly, like going away from what we can do in the real world, you can also put up video textures. So which is basically going next level where you can do projection mapping right onto your face using this technology. And if you want to like totally blow it out of the water, you can take it and make it an interactive texture where you can, as you're doodling on this texture, it's actually doing a real face paint on your thing. There have been other experiments which have like 3D doodles, which is again a new paradigm which is not possible in the real world. But what we are here limiting ourselves is to two-dimensional texture rendering on top of your face. So what we're going to share is one of the projects we end up doing for a local museum over here, which was a social media challenge for the World Environment Day, which has its own theme for biodiversity. So it's a common theme in India where school kids are asked to like do face paint for awareness and do some marches for like people to get an understanding like, okay, we need to be more conscious about the degradations we are putting onto the environment. So what we did was we put up a website with instructions for artists, digital artists to download a template. And what they came up with was shocked us as well. They drew all these amazing creations. And once you put them on your face, like you can try it out at the link below as well as an AR projection on top of your face. So today, that's basically what we're trying to achieve. It's a simplified version of this because I want it to be like very beginner friendly. And so I'll be using most of it would be ES5 syntax. There'll be a bit of promises in it. And so I'm not going into like the async await or advanced post 2018 ECMAScript syntax or all that. So yeah, let me switch screens and then we can start off. So yeah, so now we are into the editor view for where we'll be working for the most part. So what you guys can do is go to this URL. Let me just figure that. So you can go to facemesh-workshop.glitch.me. I can possibly paste that in the chat here as well. Why don't I find the chat here? Oh, there you go. Oh, thanks, Praveen. So yeah, bump up the font. Thank you. That's the feedback I've been looking for. So once you do go to this URL, you can possibly, oh, maybe not. Sorry about that. Because the thing is, like, the edit link in that won't be present. So I just want to make sure you guys can just fork that, remix it. Would that work?
I shared the link for the
Okay,
edit version where they can create a remix out of it.
perfect. Thank you. Yeah, I was just trying to get that. So basically, once you get in there, you can just pop it open, and there you will see this pop-up option over here called Remix This Project. So what we're going to have is a series of files and milestones where we can get started into it. It does take a second or two, but once we get started, we can work out towards it. So yeah, face mesh. And what we're trying to do over here is take our webcam feed, use the TensorFlow model, and figure out where the coordinate points for different landmarks are on it. Now, for that, basically what we need is the webcam itself. So if you go on to the 0_init file over here, you will see that I've got the basic header tag, which has nothing specific as such for what our project is. And then there is a simple video element. And in the script tag, we're just referring that video element. So this is our starting template point. Now from here, what we want to do is load the webcam feed directly onto this video tag. Now for that, what we've got is a navigator object onto the window itself. So we can do window.navigator, and within it, we have media devices. So this in itself allows us to get access to different media outlets within the hardware. And and that in itself has another function, property to it, where we can do get user media. And in it, we can tell what all hardware access for the streams we need. So we can say video true, but we don't need the audio for it. So we can just do audio false. Now this line in itself will go and fetch the media stream from the hardware, so the browser will talk to the native hardware and get the stream for it. Now this function in itself is promise driven. So what that means is it's asynchronous. It would not fetch the thing directly, but will return it as a promise. So we can do a then statement within it. Now, once we have it there, we can call a function which will receive its result. So we can do a load stream, which will basically be a function having a stream sent to it. Now, what's happening over here, as I mentioned, we have the navigator media devices. We ask it for specific media stream, and then itself, we just send it as a then. Once it receives it, call this function. Once we have the stream, what we're going to do is take the webcam source object itself, and then assign it this value of stream we get. Now, through this in itself, we can have a look at it. So if we do this, we see the result of it on the side. It starts for asking a permission in your browser. So that's basically a security requirement for the browser to give it the permission. So you allow it, and there we go. We get our video stream directly onto the browser itself. Now, you will see over here that it's not playing, it's just a static image. For that, what we'll have to do is ask the webcam to play it. But before we do that, there are like certain little housekeeping things which we can take care of by just making sure we assign the right size for the webcam view itself. So what we're going to do over here is do an onload event. But if you look at it, there are a lot of different load events, and we can get the information we need from a very earlier load event, which is a metadata load event. So we can do an onload metadata and use that as a way to set the size of the element itself. So over here, we know that the object now has the metadata has been provided onto the video element itself. And now we can set the stream size, the video elements dimensions itself based on what the metadata provided was. So if you might know and loaded some images in JavaScript, there is something called natural width and natural height for an image, whereas in a video, it's video height and video width. So that's basically what we're going to use to set it to the natural way so that it doesn't do any scaling and doesn't pixelate the thing for us. Oopsie, typos. And then there's a little bit pieces about making it autoplay as soon as it is ready, and then just to put it up on play. There is another setting to play it inline, because iOS or like any mobile device would not allow it to play as within the viewport itself, and it'll pop open and do it a full screen. So that's where we have to add another attribute for play inline. And if you're smart enough, you would have already jumped to the next file and seen what all is going to come next. So that's basically what we're going to finish with. And lastly, add the play bit. And now if I go on to this, we would have our webcam playing, maybe. Or is it because Zoom is taking control of it? No. Let's see, live coding is the best. Doesn't seem to throw any errors. Is this causing some issues on your end as well? It's working fine. Just want to make sure if it's not my laptop, because I'm having a video feed onto Zoom, and that sometimes has caused me issues where the video feed doesn't get loaded across two applications. Okay. And that's why we have the preloaded file, and I'm not sure what is the difference between the two. Okay, I'm just going to do like a quick comparison. Do we know if there was anything I missed? Little semicolons here and there. Okay, in interest of time, I might just skip over and move to this, but I do think it looks pretty similar to me. Anyways, so yeah, just for the interest of time, I'll just move over. There might be some other issue, but you can see we have the thing working onto the webcam directly inside the viewport. Moving on, what we want to do is add the TensorFlow bits to this. Now, if you Google the TensorFlow face mesh, they will provide you the CD and links for it. So I could just go there and say TensorFlow face mesh GitHub. Let's see. And right there, you will see the link for the code for the script where you would like to add those. You can just do that right before your script section. And this will basically go and fetch, the first one will fetch the TensorFlow library itself, and the second one will take care of the face mesh model specific files. Once we have those getting inside the viewport, we can start running and getting the model loaded for it. So we will create a function for loading the model. And over here, we have got like a global face mesh object, just because we have loaded this thing. And inside it, there are like few attributes, which are, again, if you look down over here, they will provide you all the different parameters you can set on this face mesh instance that you will be creating. So we have got the number of checks it has to do. It just defaults to 5. The detection and confidence, which default to 0.9. And the max number of faces, it defaults to 10. So that's something which we can override over here, knowing that we are limiting it to only one face. And then beyond this, there is an IOU threshold and score threshold. We'll just stick to default and not mess with those. Now, again, one thing you will see over here is this itself is also promise driven. So they are using the async await syntax, but I'll just keep it simple and make it a promise driven thing. And then once we have the result, we will call the predict function, which will take the prediction from it, and we'll see what we can do with that. So the predict will take the model which is returning, and then we will then pass in our webcam stream to it. So we'll say, take this thing and estimate the faces from this video feed. So our video feed is the webcam object which we had taken here and assigned it the media stream. And then once we have the prediction from this, we will just console log the output. And now, if I pop open the console, which it takes us time. So what happens is once it goes and fetches the model, it's going to be like a very CPU intensive initial bit where it's loading the model. And at times it might just crash your browser. So just be cautious about that. So just say, wait, it's okay. I know what I'm doing. And then let it run its due process. And then finally over here, right at the bottom, you might see this array pop in, which is the one instance of a face right in front of the webcam and showing the prediction from it. Now there is a lot in this. All we do care about is the scaled mesh. And the scaled mesh is basically providing 468 points as landmarks onto our face, similar to what we see in the texture over here. If you zoom in real close on this image, you will see that each point over here has an index value corresponding to it. And this is basically what we are getting in the result over here, is in each coordinate location in the XYZ space corresponding to the face. So if I have a canvas which is 640 by 480, my face, one of the points, the 0th point, which if we look closely enough, it might be the tip of the nose somewhere. So this is the 0th point, which is dead center, and it's saying the face was at the moment it was called at this location. And it has a perception of depth built into it. And that's why it just says like, okay, this was possibly minus 17 units far away from the camera. Cool. So now that we're here, we've got far enough for the prediction to be there. Now we have to now render it. So I'm just going to use a plain simple 2D canvas to start with, and then we later move on to a 3-dimensional ThreeJS based system. So for that, I'm just going to add a canvas element to this. Add a canvas with an ID canvas, of course. And then we will call it just like we did for the webcam. And we will also get the context for it. List.get context 2D. So if you're not familiar with Canvas, Canvas is a way for you to draw raster-based or pixel-based drawings within the browser. This in itself has few attributes that you can get a context for, which does all the heavy lifting and has all the functions associated with it. One of such context is the 2D context, which has a lot of helper functions for help you to draw primitive shapes. We are just going to restrict ourselves to small little rectangles, but for that we also need the context. So once we have that, just to make sure we align things really well, I'm just going to make sure the canvas is sized as our video as well. So we're just going to take the webcam video height again and set that same as this. So right now our canvas and the webcam feed are both aligned in the dimensions, so that once we draw and take the scaled mesh coordinates, they map really well and match onto what we have from the webcam. Now, the prediction basically over here was giving us the values that we need. So what I'm going to do is take those and then put them in a render function so that I can see the dots coming in. So what we'll do is take the values from this and put them in a function which we can just call update predictions. If I can spell it. And over here, we will get the predictions which we were earlier putting it in the console. Now, the thing is, we can use these predictions directly and do one single render. So we can possibly try that. So we do predictions, and within that, you might remember it was an array itself. So for each face, it puts out an array. So we just use one face because we've already told it that there is only one face. And then we added a scaled mesh. And in that, what we're going to do is take those positions and loop through them and draw a rectangle out of it, or draw a rectangle for each of them. So I can take this and set this to positions, and then take these positions and do like a simple for loop. Whoops. And var I equals 0, I less than positions dot length I plus plus. Now, once I have these, I can now get the XY location, which is basically positions I0. So if you might remember from the console log itself, it was spitting out an array of arrays, and each array has an XYZ. So we're taking the X and the Y because we are using the 2D canvas. We don't need the Z value. We can possibly use that and scale it and like show the rectangle to be bigger or smaller as compared to like the depth of it. But we're just going to keep it simple for now and have the same size values there. So we can do a fill rect, which is a function on top of the context, which we are using to draw the rectangle. And I'm just going to keep it simple. The API for this, basically the function is the parameters it's asking for is the XY location, the width and the height. The width and height, I'm just limiting it to 1 and 1. Now, this in itself wouldn't do anything because we have to set the paint color. So if you have used MS Paint before or any other of these paint tools, they have a palette in which you have to pick which color it will render with. And once that is assigned, it's going to fill that, whatever shape it does next, with that color. So that's basically what we're going to put over here. So we're going to do fill style and just call it black for now. And now if I run this and if the demo codes are with me this time, we will see a little dot shape once everything loads. We should just pop open the console just in case. it has to do is think. So every time like browser asks, like, do you know that you're asking too much of CPU resources? And then voila, magic, we see those dots. So basically it took a snapshot of that once the function was called, got the values for those dots, and those there they are. You might remember seeing something really similar in the GIF over here. So this is primarily, if you go through the demo in this, they are possibly using the same technique to draw the rectangles on top of the points, which is being shown as a prediction. So far so good. I just want to take a minute over here, make sure everyone is caught up if they have any questions, and then we go and proceed further. Cool. How are we doing, Praveen? Are there any questions or things that I can answer or help with?
Yeah, I'm looking at the chats.
Okay.
By the way, can you increase the font a bit?
Oh, okay. Oh, yeah. Maybe I think somewhere in the process it got shrunk again. Sorry about that. That bug kind of threw off. Is this better?
Yeah.
Yeah. Cool. So maybe in the interest of time, I'll move forward. Please feel free to ask any questions in chat, and I'll do our best to solve those. So now we've got the points. They look good, but it's just a static image. Now what we want to do is run them every single time and render them. Now this in itself is the prediction part. So maybe what we can do is run a render loop. So we can create a simple function for render. And what that will do is call the request animation frame, which is another nifty little API for doing JavaScript-based animations, which is called every 60 frames. It tries to call every 60 frames unless the render loop is more intensive. And you just pass in the function. So you might think this is going to go into an infinite loop, but that's basically what we want because a render has to go every time till we tell it to pause. So this is what we're going to do. We're going to constantly render these points and go loop through the positions. Oops, loop through the positions each time. And because the position variable would no longer be in the scope, we just take it out and make it a global variable. And over here, what we're just doing is updating the positions. Now, this will constantly run with the same positions. What we want to do is every time there's a new prediction that comes in, we need to go back and call for new predictions as well. So that's what we're going to do over here. We're just going to go and call the predict thing again. Now, we might see over here that the model itself is also locally scoped within it. So we will have to make that universal as well. So if I were to say over here, call for predict the model, there is no model variable in this scope. So what I'll do is create another global variable called face mesh model, which I will update over here if it hasn't been declared so far. So if there is no face mesh model, please go and assign the model which you have found to it. And from then on, just use that model. Now, this face mesh model variable is now globally available, so I can use that to call the prediction function again. Now, this will go and call the prediction every single time and also update predictions value. Now, there might be an instance where the predictions might return with a null, or like with an empty array, and we don't want to totally make the canvas go blank for that case. So what we're going to do is take care of that instance over here and not update the positions if there are no predictions from the model itself. So if the predictions length is 0, we're just going to call return, and that'll be end of it. But if there is some prediction, we just update the positions value. And now what I'll need to do is just call the render function, if I spell it correctly again. And hopefully this should do it. Let's see. And now it'll do its dance, make sure the model is loaded, and call for a warning that it's taking a lot of CPU resources. And there we go. And I'll just call it wait. Surprisingly enough, like I'm working on a MacBook Air, it does take care of like a 2-monitor screen with a GPU model running and is predicting, and it's creating this fancy painting through my face now. And you take your face as a brush and draw on it, but maybe you don't want that. So what we need to do is clear the frame each time it's rendering. So that's where we do context.clear rect. And there we have to mention the amount or the area of the canvas we want to clear out, which is the full canvas currently. So we just take the canvas.width and the canvas.height. And this will basically make it, till it loads, do that. So locally what I did was I went into the JavaScript files, opened them in a new browser window, picked where it is fetching the model files and downloaded those separately and pointed them locally onto my thing so that it doesn't go and fetch like 3 MB of data every time I open the browser window or refresh it. It does do some caching, but at times I have to open it incognito so that the other caching also doesn't come in the way for my local file. So right now we have the thing running in an infinite loop, and it's constantly predicting everything on the client side. No data is being shared on the server. So voila, magic. So we've got it in 2 dimensions working. The thing over here is that these are just dots. Now, to make it like a mask-like thing, we have to connect these dots. Now, you might wonder, like, how would I know which dots I have to connect to make it a solid shape? Now, just for that instance, if you go into the GitHub repository again, there is this file in there, I think in scripts, no, maybe not there, in the source. In the source, there is this file called triangulation. Did they change things? Come on. Oh, in the demo. Sorry about that. So in demo, there is this file called triangulation. It's copyright Google because they defined where the face mesh coordinates lie. But you can use those for your project right now because you're not going to use it commercially, I think. So what I've done over here is in the project itself, have that triangulation file already preloaded. So what we're going to do is just fetch that file right in here. Call it script. Sometimes it works with these little shortcuts. Sometimes it doesn't. I don't know what glitches after these days. Okay, triangulation.js. And there we go. I hope I spelled it correctly. And with that, what I'll do is instead of just rendering those dots, I will get the triangulation value. So now instead of looping through the positions, I'm going to loop through the triangulations. So if you go in there in the triangulation.js file, there is this global variable that will be created now for you, which you can loop through. And then we just, and okay, so what's this about? I need to go through that. So what this is telling us is the positions that you are getting in the scaled mesh is a flat array of all the different coordinates, or a 2-dimensional nested array. If you go to position 127, 34, and 139, I don't know if I can find that in this yet, like right away. But say, for instance, I see 103, 68, and 104. So if I go over here, search for 103, Da, 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 da. So 104, 103, 104, and 67. These are the three. Oops, I should mess with this. These are the three which will form a triangle. So if you iterate over three at a time, each of them is a triangle. And those are basically the points or indices of the position array in itself. So what we're doing over here is we are looping through this triangulation three at a time, and we're gonna get the points A, B, C of a triangle by going through triangle. I just copy paste it now. Triangulation I is the index for vertex A, index and C. And over here, I'll just do +1 and +2. So these are the indices for the triangle values. Now, once I have these, I can then get the specific coordinates for each of them. Now, to draw a triangle in a canvas, you have to use a path function. It's very much similar to like if you have done CSS path, there is this D equals to, and then you do M, and then you have like X1, Y1, and then you do an L. The same thing in JavaScript for Canvas is you do a context begin path. This will basically start a new shape. And then for the first point, we don't want to start from 0, 0. We want to move it to a particular point. So we do a move to, and this will take an XY location. So the XY location for this is the specific index we have figured for vertex A. And then over here in itself, we take the X part, which is 0. So positions A, and there we go. So we've got to point 1. Now, once we have got to the first point, we now want to draw a line to it. So we do a line to, and instead of A, we will do B. And lastly, we will do it C. Cool. Now, once the path is done, if you loop through it again, it doesn't know if you have ended it. So we have to now close the path. Now, weird enough, beginnings have endings, but in JavaScript, beginnings have closings. So we will close the path through this. And again, you might remember earlier we were using something called a fill rectangle right here. Over here, we'll have to specifically mention that we are going to fill it. And by default, the color is already set to black. So now if I run this and let it do its little loading dance, I should possibly see. How are we doing on the chat?
I shared with Joe the ID. I think he came late, so the link was not shared.
Okay. There might be some error here. Maybe not. This is taking its sweet time. Okay, my laptop's fan is now spinning crazy, so I'm putting it to its limits. Should I just refresh it? Doesn't show any error. Let me see if things are going fine in the network tab. There we go. So yeah, so this is where it's fetching the models from. You can see it's like 2.8 MB. Currently it's 302. That means it's just getting it from the cache. Still, it takes a toll on the processor. So the browser gives us the warning, and something funny is happening. Oh, maybe I need, okay. I think I've assumed that the fill color is black. Maybe it's doing the thing, but I should just do that just in case. Because I think I'm coming from like a bit of P5JS work as well, and I messed up the syntax. Awesome. So yeah, there are things which some libraries do and some don't, and that's where. Come on, there you go. And it's a moment of surprise like this. Drum beats. And come on. I should just do. See, I can definitely get the bottom of this, but I don't know how much time I should be spending on that.
Sometimes it doesn't catches you when your mouth is closed. So when you open your mouth like this, no, then it catches it faster. I don't know.
Okay.
There is some glitch.
Maybe it knows we are on glitch. Okay, there is, so the array has not been updated. Prediction start length is 0. It's not getting the predictions. Interesting. It was working in the previous version, but suddenly it decided not to work. Or maybe because I never allowed the webcam. Oh, very bad of me to do that. This will give it a second again. Another thing I noticed was it's way quicker on the Mac on a Safari. Maybe like their WebGL implementation goes directly to the onboard GPU I have, and that's why it just runs faster for me there. If that the loading thing is constantly causing an issue, I can just move there. But so far, it's not telling me what's going on. Let me see again. Okay, there are positions coming in. So there is something wrong in the render loop itself. Move this inside. This is the last attempt. If that doesn't work, I'll just move on to the next thing. Really stressing my laptop out now. It's just like even the warning label, it looks like. Okay, we can debug this later then. So something funny is happening in the render loop. I'll check forth for it and get back to it. Maybe we can just skip the steps. So we are currently on to file number 5 over here, just to make sure. It does look like most of the things are in place from where we wanted it to be. I'll give it a shot anyways. So yeah, we'll just run this, change URL, instead of, let's refresh thing and run the triangles one. Now, if this one fails, that will be the end of it. No, just kidding. I do see that I have, okay, there we go. So we are seeing the little triangles popping in. The white edges you see over here is basically we didn't draw a stroke on the triangles. I left it as it is so that we can see these are individual triangles we are seeing. And you can see the lip movement and everything being tracked through this polygonal shape we've got. Now, this is where we might have like a fork in the road and we start doing a bit of ThreeJS work. So again, I'll give it a pause over here just to make sure everyone has caught up, things are working on your end, and so that we take it up for the next leg of it, or the final leg of it. And you can also stand up and take a stretch. That's always good to have. Cool. How are things, Praveen?
Like no questions yet.
Okay, that's a good sign or a really bad sign. So we'll see for that. Maybe in the meantime, I can have a look at what really bummed it over.
It's the fill style, I guess.
Yeah, I think so. But why should it matter is what I'm curious about, like where I put it.
Even
Because
I am thinking that.
once it's universally declared, it's just should just work. Dum, da, dum, da, dum, da, dum. Yeah, I don't know. Triangulation, spelling's right, everything's fine. Just give one last shot while we're waiting for anyone questions or if anyone wants to go for a quick bathroom break or something like that. Still not budging in. It's like a really weird piece of code now. That's not working. Okay, I should possibly. Do we do like a 5-minute break? Would that be a good thing?
Absolutely.
Sure. Because yeah, the next one is going to be the final leg. I just want to give everyone a chance for that. So, oops. 5-minute timer. Okay, start. Start. Ooh. How bad does it look?
Looks pretty good.
Okay.
Folks, we're going to take a 5-minute break. So if you want to go get some snacks or a bathroom break or anything, or if you have any questions about the presentation so far, feel free to drop them in the chat in YouTube on Zoom as well. And we'll do our best to get to them. But if not, we'll be back in 4 minutes and 30 seconds.
I just saw your text message. Sorry. I missed that, the font size bit.
In my system, I can't use both the cameras together, so I have to switch it off the stream sometimes.
Yeah, I think it's a Windows thing. In Mac, I haven't faced that, but I was just curious, like, why would that not work? So far, like, there are two seemingly identical looking code which don't seem to work. I'll see for it. It's okay. I'm going to try something here. Maybe not. Ooh, what happened? Okay. Oh, there was this thing about the gallery mask gets misaligned when. Okay. Yeah. Yeah, I think I should just restrict that piece of code to one orientation only.
Okay, that code works for me. I don't know why it was not working.
Okay, yeah. Now I'm thinking it could be a caching issue, like it's just retaining an older version of the file. It's doing this like here, little weird pixelations on the CSS animation or what. Later. Cool. I hope everyone's back. I'll just give another minute or two and then we'll resume. I'll just do a bit of like housekeeping kind of things. So now that we're moving to like a totally different setup, I'll just create a file for ThreeJS. And it will mostly be, I should take the initial chunk of code from here. That's about it. Okay, assuming everyone's back, I'm just going to resume. So what I did over here, if you missed this, I just created a new file, just called it ThreeJS, and copied the code from the last file we were on, triangles, and got this bit in here. Now, currently we won't be using the webcam bit, so I'm just commenting this piece out. And in there, what I'm going to do is create a script for ThreeJS. So I can just Google ThreeJS CDN, get the first link, and over here, we'll take the min file, copy that script, script source, and then just close that, and we're good. Now we have the ThreeJS loaded. So we will just write some code for it. So yeah, ThreeJS. So ThreeJS basically takes in the canvas, which we have, and puts out a scene and a renderer. So if you've used any 3D software before, it's usually you create an environment and you can place different objects in it. That's basically what we're going to do just through code. So to know where it's actually drawing the things, we're first going to fetch the canvas itself. There are multiple ways to do it, and just doing it for the reasons we have already been, the format we've been using. We can just pass in the ID as well. And I'll just predefine and set a width and a height. Later on, we'll just assign it to what we have from the webcam. So we take these values, get it set and rolling, and then we create something called a renderer. So this is basically which is going to render the scene at every render loop. And we create this thing through it's all caps, 3.webgl renderer. And in that, we just have to pass it the canvas element we'll be referring to. Now, there are fancy syntax where you can just pass in the key if the value is the same, but just for legibility, easy for readability, I'm just going to copy it. So once we have the renderer there, we need to create the scene in which we will have all the objects in place. So we'll create a new scene. Again, pretty much similar to the thing. It's a class, so first letter capital, and that's about it. Now, next up, we need to have a camera. So the thing is, usually in a 3D scene, you will have a perspective-based camera. Oh, sorry. Yeah.
Samarth, can you close one of the screens? I think both the desktops are shared.
Acha. Both the desktops are shared. Okay, is that better?
Yeah, better.
Cool. So we have created our basic scene, and through that, now we need to have a camera. So usually you will have a perspective camera, but now what the way in which the TensorFlow model predicts and creates the mesh for the face, it uses the orthographic projections. So for that, we need to create an orthographic camera. So we just create a camera thing, and we use 3 again. I've got like this really bad habit of not putting in all caps, and then orthographic camera. So if you look it up, what the orthographic camera for ThreeJS is, it will be expecting certain values. So it takes in width by half, height by half, 2, and this is the default. I'm just going to use those. And maybe I'm, again, forgot to put the capital O. Now we don't have the width as it is, and because it's being repeated, I'll just create a variable for it. So we'll just call it half W and take the canvas width and divide it by 2, and same for the canvas height. Cool. So this basically becomes half W, and half H, and half H minus half H. What this basically is telling us is the viewport width. So because ThreeJS would have its coordinate center at the origin right at the center, we will take half the width wide left and half towards the right. Same for top and bottom. And this will basically be the cone of vision for the viewport of the thing. The next setting is for the near and far. So if you take a pyramid and chop its head, that basically becomes the frustum, or the range of view. If you have played like older games, it basically allows you to tell how far in the horizon, till the horizon you can see. And this is what that is defining, how far down the line in the Z depth you can get it, and how near the camera you can see it. So this basically puts out the settings for the camera. Next up, we want to place the camera somewhere. So for that, we'll do position.x. And again, we want to put it dead in the center so that when the projection is happening, we don't miss out on either edge of it. And same for the y. The z value is a trick in itself. So I'm just going to start off with somewhere randomly from halfway from where we want to do and set everything accordingly. Now, the fun thing in ThreeJS is that it allows you for the camera to look at a specific point. So what we're going to do is look directly at the origin in that sense from wherever it is. And so that's where we're going to put it. And next up, once we have got the camera loaded, we're just going to put in a light system. So we're just going to use a simple sun-like light. So if you go and see ThreeJS light, there are like all these different light variations in it. Search for it here. So you can see all these different ones. I'm just going to use an ambient kind of light, which is the hemisphere light. And you can just copy the piece from here. And that's it. So because it's very much ambient-like, we don't need to set a position for it. And we just add that to the scene. Now you might wonder why I didn't add the camera to the scene. So the camera is basically assigned to the renderer, where it's going to take that perspective from that camera and then use that to render things. Next up, before we jump on to using the face mesh, I just want to show how we can render something in ThreeJS as a simple shape using a list of positions we manually set it. Now, there are easier ways to draw a geometry, but because we are going to use those coordinates to draw things, which the face mesh model is providing us, we're going to use something called a buffer geometry. Now, a buffer is basically a chunk of data which we just pass on to the WebGL renderer directly, and that it takes the value in a certain manner. What that is basically a flat list of XY coordinates of the different vertices of the triangles. Now, it could be different shapes as well. I think WebGL2 allows for quadrilaterals as well, but we're just going to keep it to triangles and use the default things. So we're going to create a geometry, which is going to be the buffer geometry. And if I always remember to type in correctly. We will have this set up, and now we need to define what those positions would be. So we can do position buffer data. And let's assume we want to set a rectangle in the viewport. So we will start with the leftmost point and draw, okay, let's just do that through like an ASCII art thing. So let's say this is our rectangle. So this will be the point A, B, and C, and maybe D, and C, right? So if you look at point A, this is going to be 0, 0, whereas point B is going to be canvas width, right? The full width on the right edge, and then 0 on the y-axis. C is going to be canvas width and height. And lastly, we will be back to point D where we just have the 0 over here. Now, if you would like to, you can indent it nice and clean so that everything aligns. And it's easy to read. So now we have got X, Y, X, Y locations for the position buffer. Now, once we have that, we need to assign it to the geometry itself. So we take the geometry and we set an attribute for it, which is going to be the position. And this will be a new floating point array list because that's the format it accepts these values. So what happens is WebGL is a typed language. So and JavaScript is loosely typed. So for us to send data to WebGL, we have to convert it into a typed format. And the typed format which JavaScript provides is a float32 buffer array. Now we take that simple array which we just created as a position buffer, and ThreeJS provides us a helper function to create that float32 buffer attribute for us using this. So this attribute is basically what will be loaded by the vertex shader in the WebGL through the position data we are sending. Cool. So once we have those positions, now it needs to understand how do we make a polygon out of it. And it's similar to what we do for our triangulation. So we will create our own triangulation, much like what the face mesh model provides us. And now let's say we want to draw a triangle ABC. So we're going to take the index values for each of them. And this basically takes in how much each of them skip ahead for it. Okay, one thing I possibly missed over here is because we are going to do some texture mapping, it will expect a third dimension value as well. So I need to mention that all of them are currently at the Z depth. And I've got like a rogue comma over here. So if this is our position A, and that was basically what the 3 over here was, that skipped 3 values at a time and read them simultaneously for a vertex position of each vertex. And once we have that thing going, now we need to tell which 3 vertices, indices of which 3 vertices make up a triangle. So we can just say ABC make 1. So if we have to declare ABC as a triangle, and we see over here, this is A, this is B, and this is C, and this is D. For ABC, it's going to be 0, 1, and 2. Again, this is also a flat list, but the way we are indenting it, it makes it easier for us to read. And the next one we're going to do is going to be CDA in the same circle. And so for CDA, it's going to be 2, 3, and back to 0. So C, D, and A. Cool. So once we have these, now we can set those to the position buffer or like geometry itself as a set index property. So we take the geometry and we do a set index. And over here, we just gonna pass in our triangulation array. Cool. Now, another thing which a 3-dimensional renderer would need to know is how does light bounces off it. And that part of it is through normals. So any light that comes through it, it calculates a normal, a vector, which is perpendicular to that plane. We can manually provide it, but because we won't be able to get those normals for a face mesh, ThreeJS has a helper function to calculate those normals for us. So we can just say compute vertex normals. And that's about it. So this will basically create a geometry that we need. Now we can add some fancy layer to it, have a material so that we can put in some colors. 3 dot. Now again, just like lighting, you can look up what all materials are provided, but we can just go with the very basic one, which is the mesh basic material. And you can look all the properties you can assign. We just go with a basic function for it. And then in that, we just assign a color. This could directly be a simple color, but there are a lot of other helper things which this can provide us. So we'll just go the extra mile and define it. So you might be familiar with the hexadecimal syntax for defining a color in CSS, where you can just say like do something like this, and you have like simple color. Now the same representation for the color can be represented as a numerical thing by doing 0x and followed by the value. So this is exactly equivalent to what we were doing with in the CSS. So that puts the material in place. Now, once we have that, we have a geometry which defines where the vertices are and how they are positioned. We have a material. We can now create an object which follows that geometry and that material. So we create a mesh, which will be again a new 3 dot mesh. I always forget to make it capital. And then geometry and material. Cool. And now lastly, we'll just add this to our scene. And the renderer will render for this particular scene with the camera we defined. Looks good. So we go down to our 3.html and something did mess up again. Did I? Or maybe I positioned it. So maybe the normals are flipped and that's where it's kind of not getting those specific ones. Oh. So there is this orthographic one which bums over every time. I have to correct it for. Color is valid one, right? So I faced this problem when I was creating this thing as well, or maybe the light data is kind of fucked up. There we go. So we took, so basically the light was putting a deep shadow and we weren't able to get that. So we just put it like a white light, and that fixed a bit about it. So now we've got like a simple thing running, and I messed it up again. Wow. Okay. There's something funny happening, but it's not. I will just do it. Any ideas?
Can you check the console?
Yeah, but I don't think. Yeah, that's what I expected. There shouldn't be an issue there. Oh well. So we might have to skip and do the pre-prepared file for this as well, which again, I don't know, looks fairly similar to me, but at times it just bumps me. Anyway, so we'll just skip over to the file number 6 and now move on to adding a texture to this thing. So we've got like a simple triangulation thing, but for the material itself, we are just filling it with a single color. What we're going to do now is use some UV mapping to put up a texture file on top of it. So if you are familiar with doing some of this UV mapping before, we are going to define where in an image. So let's say I'm going to load this particular image onto the canvas, and I will have to tell where each coordinate, where the coordinates for each of the vertices, which I've mentioned in the position buffer, lie. And these all are normalized 0 to 1. So we're going to use that as a start. So 0, 0, and then that's going to be A, and B is going to be 1, 0. C is going to be 1, 1. And then lastly, it's going to be back to 0 and 1 again. Cool. So once we have that, we will create a new attribute where we will pass on the UV for it. And this again is going to be a float 32 buffer array. But instead of being passing 3 points at a time, we're just going to pass 2 this time. Cool. And apart from that, we will have to define where the texture comes from. So a texture in ThreeJS has to be loaded through its own specific class, which is a texture loader. So we create an instance of that class with 3.texture loader. And in that, we will get our texture loader dot load. The weird thing about how Glitch takes its assets is that it loads them onto a CDN so that it loads quickly, and it also adds like a helper parameter at the end of it for versioning. So we have to go into assets, grab that link, paste it here, and this extra parameter you will see over here is for versioning, so that if you do update the same file again, it creates a new URL for it. So once that texture is loaded for us in that material, instead of just using the color, we will pass in a map for that texture so that it's mapped onto those values. And with that, it should get those files for us. And again, it bums me out. Huh. design. There is something funny happening with Firefox. I'm just testing it on another browser just to make sure. Yeah, no, not loading here as well. I wonder what's the problem. Does okay? I think I got that where it was failing in the previous one as well. So the first initial render is not ready by the time, so we'll have to put it in a loop, and that's what it was bumming it over. Welcome to 3D rendering. You know, the weirdest problem of 3D rendering is not just this. There is always, so there we go. So we get the image up, and I think in the previous one also, if I go and put this piece there, it should get the color. Yeah. Dun, 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 dun. Maybe not. Okay, we'll leave that for now and move back to the previous file. So you might be wondering why this thing is not upright. It's because of the camera settings we've got, and we'll get to those as well, because surprisingly enough, face mesh, when it loads its things, the orthographic settings, either you have to loop through each and every point, because that's what next is going to happen. You have to loop through each of the points and flip those, or we can just use this and flip our camera coordinates and not make it a CPU intensive task for each frame. I don't know how much of a performance gain I will get through that, but I just feel comfortable doing it. So I just go for that. So the next piece, once we have this running, is to take the code which we had in the loop and paste it on top of the thing itself. So we just take all of this over here. We might have a conflicting error function with the render. We'll take care of that as well. So we can comment this bit out. And we also need to copy over our little thing for loading the TensorFlow files. Again, might be good to close this up because it might throw a lot of errors as we are coding our way through it. And right. Now, another problem while we are using this simplified version of the code is that our canvas might not be ready in the dimensions it should be for loading the webcam. So a hack in here is I will predefine what the dimensions of this thing have to be so that I don't have to like wait for it to load. Now, there are ways to bypass this, but just for our own sanity and keeping the code brevity, we'll just predefine it to be a standard webcam kind of resolution of width and height. Okay, and so all of this piece of code can now come up over here, and instead of using this, we can just paste this, and same for width. Again, you can do a command D to get double cursors and save like a few of the key presses there. So this will we had our width, which again is width, and height, which again is height. Cool. So with this, we are pretty much good in terms of prediction, updating the positions and everything around that. We have commented out our render loop function because instead of using that, we will be using something from ThreeJS, and we created our renderer. We did all of this. And now instead of the position buffer data, now this is another problem which I faced, and I'm pretty sure there are smart folks out there who would have solved it better than this. But my personal workaround has been to just have a cold start data preloaded. And so what I'm doing over here is take this script tag, and I've got like an initial values for position buffer data. And that way, once it is being loaded, I can spell it right, it is ready for prime time, and it just gets it running. So the positions I will update through this, but the initial position buffer data is being preloaded. So I can just remove this. And if you go onto the position buffer data, we already have an array in place. Sorry. Similarly, for triangulation, we can go back to the loop one, and the triangle one, and copy over our script file for triangulation. And we go in and add that. And once we have both of these in place, there is one last piece remaining, which is the UVs, which is in the texture map file over here. So I will go there and add that. And so if you go into the texture map file, this is all the coordinates for loading a face mesh array for all the vertices for the specific mesh we are using, which is this. So it's taking in all the coordinates and XY location in relative terms, normalized for this. So we get through this, and now we've got the triangulation and the UVs, so we can comment these out as well. So the position buffer data is preloaded, texture is there. Now in the render loop, this is where we will take the new predictions and re-render them with the new pattern that we've got. So what I've got over here is I'm just going to take the values for the position and see what we can do. So if I'll definitely render it here. So we take the positions. So if there is an update and there is nothing in there, just like we did in the previous version, we will skip this part. Sorry, return. And if there is an update which has new data for us, we will update the default position buffer data we've got. And so the funny thing is, because you might remember the scaled mesh, which was returning positions, they were nested array. So now we have to flatten the array. So we can basically use a simple flat function, which would work, but this is like a very ES 2018-19 method, which might not work. So what I usually do is search for flat JS ES5 something, and Stack Overflow usually has the answer for it. So there will be like a reduce function, which will take that. So you can take the copy apply method, or usually like the little this one, and you can take that and flatten an array. So, and then we just take this position one, pass it to flatten, and that should take care of most of what we want. We get the flattened array for the position, and now we need to update those. So we take this and we reassign it to the new position buffer data. And then we also tell ThreeJS that this attribute has been updated. So for each render loop, kindly recompute the things needed for it. And so we do that by saying attributes that need to be updated. This is basically clearly defined in the documentation, where it will try to be performant by skipping this if you don't tell it to. So you need to explicitly mention that over here. Now, by means, if all goes well and the demo gods are with me, we should see something happening here. Webcam is null because I commented the HTML element out. Creating a virtuals thing. See what's that about. Is this because I'm using a different version of GL? Just make sure it's there. Maybe not. Oops. Yeah, so there is something funny happening with the ThreeJS renderer. Let me see where we are on that. Did I comment a piece of it out as well? No. Let me just reload this thing. Definitely something wrong with. So let's first so it's doing its thing, loading the TensorFlow model and doing all that. I'm just gonna comment that piece out for a second and see what's going wrong with the renderer. Because I had a 2D context. Silly of that. So basically, when we copied over, we had declared a context for the canvas, and it shouldn't be a 2D context for the thing. So maybe that was doing the thing. So yeah, we see the canvas there. That's good. And if it'll do its trick, which takes a time to load the model. But this time around, didn't trigger warnings. I'm just curious if got stuck somewhere else. Oh, well, because I commented it out. Amazing. Okay. Cool. There we go with the warning sign. We're making progress. Ooh, position is not defined. Positions, is that it? Tell me that is it. Positions, come on. Yeah, type was hidden. Okay. Warning 1, warning 2. And we see something coming up. So now it's all about, so this is what all rendering is about in 3D. It's sucking the soul out of the whole computer. Also, you have to blindly guess all the camera settings so that it works fine for you. So most of this time, it's personally for me, it's trial and error, but I'm pretty sure there is a better way around it. So what we do is flip it out and say, position it behind the user. So that, because what you're seeing is the outer edge. So that basically means that it's, the normals are reversed and the camera is too far ahead. There is a way where you can put like an orbit controller and have a debug camera and make sure like you go through all of that to test it out. I'm just closing some other tabs to avoid it like saving some of the RAM. And voila, there we go. So it's all rendering in 3D. There is a significant lag on my laptop. Let me just make sure if the render loop is not stuck somewhere and it's not updating, or it's just the lag. Okay, so it might just be the lag because I see everything updating really slow on my laptop. So a caution, a word of caution for everyone: don't hog your the GPU so much that it's running TensorFlow. It is trying to render things with WebGL, and it's also doing a screen share with an extended monitor. So it won't perform as well as you would expect. What we've done is reached to the point where we can look at the final code, and I can do like few edits which we have put up here so that it works well. I'll just close this thing because it's just putting my laptop on its knees. So the slight differences over here is in the renderer itself, I've put in an anti-alias and an alpha. What that does is, instead of having a black background, oops, was my microphone off? Okay, again. There is the anti-aliasing makes sure the edges are smooth, and the alpha makes sure like the black background we were getting is transparent instead. The next bit over here is I've changed the texture to one of the creative ones from the cultural mask, which I showed in the slide. And then with that, I've changed, there's a different reduce function going on here, which is for just making it a one-liner. It's kind of like code golfing. I was trying to avoid anonymous functions throughout this code, and I forgot, like I left it here. But anyways, so now if you pop this open and see the final version, and just close all these tabs. One fancy trick you can do is make the canvas position absolute. And what that would do is overlay the canvas right on top of it. And that way, it just looks like you are wearing that mask. We can just do like one final edit for that. If this loads as well. And there we go. So this is the mask. We have like an added color on top of it, but for the most part, it's doing what it should. The last piece which I mentioned, we can go over here in the style tag, make sure the webcam and the canvas both are position absolute, and we make it left 0 and top 0. This way, when we load it, it loads right on top of the face, and then it'll do its own trick again. But yeah, I think it conveys the point well about what we're trying to do over here. Once we have this on top of it, there's another trick you can add is take the canvas and add a mixed blending mode on it and do something like a multiply or a screen. And that basically takes the video element and puts it on top of it. Again, it's not working as performantly on mine, but as I said, like if I run it on Safari, it usually does better. Another thing I've noticed is if you're looking head on to the webcam, it usually performs better, whereas at a different angle, it does obscure and makes it really hard. So the other last trick to make it face paint is to just take the canvas element and in the end, just add mix blending mode or blend mode. I forgot this. And make it multiply. Just go do that real quick. Loading. Let's mix blend mode. So yeah, are there any other questions, concerns, things that missed out? So now you can see it's kind of multiplying on top of it. Again, if I open it up in Safari, I think it will be a bit more performant. We can just do that as we take any other questions or things we have. Oh.
Right. Does anybody have any questions? Feel free to drop them on Zoom or YouTube, and we'll be reading them, and Samarth will be answering any questions you may have. Okay, I think there are no questions. Anything you would like to highlight or any final thoughts? The whole thing was so cool, by the way. Like the final result is so impressive.
Thanks. Yeah, I think apart from like those little glitches here and there, I don't know, I try to make it as seamless as possible. That's why like I had like little milestone files. So I think those would have helped for everyone to walk along and get an understanding of what's going on. So originally we thought of like doing a code walkthrough rather than type along, but I felt like if that usually glosses over a few things, it's better to go step by step. And yeah, there are a lot of moving parts here, and we start with something like as deep in itself as TensorFlow, and then move all the way covering again an ocean of itself as a topic is ThreeJS. So this is like a very initial gloss over things. We are just using the libraries as an application layer. We're not training anything in TensorFlow yet. We're just using off-the-shelf models. One good thing, as I've said, is this works really well on smartphones as well. So once your creation is ready, all you have to do is replace the asset file. Just make sure like all the face attributes that you're creating are mapping well onto the texture reference stencil we have provided, and that should just work. So you make sure the eyes are at that same location, the mouth is at the same location, and the nose. And once you re-render it with the new file, it should just work splendidly well. And you can try whether to make it multiply or versus like have that mixed blend board or not, whether you want that multiplication with the video feed or not.
Awesome. So we do have a question from YouTube. The question is, how again did you get the point data from the mesh? Can you go over that real quick?
Okay, just one sec. I had loaded in Safari and now it's taking a time. The whole laptop is lagging. I'll shut that first. Okay, am I back? So the question was about getting the position data. Was that about the original position data that we have preloaded, or how?
Yeah, the question is if you can go again on how did you get the point data from the mesh?
Point data from the mesh. Okay. So if we go, I think it'll be better if we go through the predict one once time. So basically what we're doing over here is once we have the webcam running, we know what aspect ratio and everything for the video feed is going to be. We call in the load model function, which basically takes the face mesh object, loads that model for that specific configuration we want. And then we call in the predict model, which basically takes the video feed and asks it to estimate faces out of it. Now, if you look at the console log.
Hang on, Samarth. You're not sharing. I don't know if you think you're sharing, by the way.
Oh, I'm sorry.
No worries.
So yeah, onto the predict file. Is this is visible now?
Yeah.
Screen? Okay. So are you seeing the code? I'm just making sure it's the right window.
Yeah.
Okay. So basically what we were doing in the predict file over here was calling the load model, which set the configuration for it. And then we call the predict, where it passes on to the model. And we ask it to estimate faces based on the either an image or a webcam feed, which will take the snapshot at that particular instance when that function is called. And it takes that output and logs it out. I don't know if I should log it because I'm seeing that the laptop is suffering a bit with all the pounding I'm putting it through. But let's give it one more try and see if that works through, and because it might be worth it. So once we do get that prediction, I think I did do a quick gloss over the whole thing rather than giving it some time. But maybe that's where the question is arising from. So yeah. So this is what the prediction we get. So if you see that in itself is an array, for each face, it will have an object, and that will itself have different properties, which would be, if you go through the GitHub, it walks you through each of them. But for our needs and purposes, we just need the scaled mesh. And if you look through it again, now there is a difference between a scaled mesh and the normal mesh. The scaled mesh is relative to the size of things of our canvas. So this makes it easy for us to render. And in each of them, we have basically 468 points. And each of those points have the X, Y, and the Z values, which we are then passing along to the position buffer array. So that's where we were going through in the dots and the triangles. But in the final piece, what we were doing was, now ThreeJS, like you might remember from doing that simple example we did over here, was to basically have these positions as a flat list of XYZ points for each vertex. That's basically what we want to convert the scaled mesh into. Now, because it's a nested array with 3 points each for X, Y, and Z, we take that and flatten it. And this is basically what we're doing over here. We got the scaled mesh into positions, and we have reduced the reduce operation basically flats it out into one single array. And we pass it along to the position buffer data, which is very much similar to what we did in the previous file. Hope that clarifies that.
Cool, thank you. Any more questions? No, I think we're good. So thank you so much, Samarth and Praveen, for sharing your knowledge with us today. It was an amazing session. I personally learned a lot. It was a lot of fun following along. So thank you again for being with us. We really appreciate it, and we hope that everyone had a good time and was able to follow along and found this as interesting as we did.
Yeah. Thank you. Thanks a lot for having us. It was amazing sharing things because we've been working on this for like almost a month now, and it's really great to like give back to the community from what we've learned. There was like one piece which we kind of, I would say, was a novelty in itself, was creating that UV projection map. And I think this definitely helps artists who don't want to get into like learning code or doing things, where they can just pop in and replace a file, and it just works as an AR filter for them. And also for people who might not have like a depth sensor based camera. So those are the things which we're trying to see. We can liberate artists from these proprietary softwares and ecosystems.
Definitely, and it's definitely super different of what you would normally do at like your day-to-day job. Yeah. So it's definitely fun to play around with these kind of things, right?
For sure.
Amazing. All right. Thanks, guys. We really appreciate it. Thank you, everyone, for tuning in and for being with us. We hope that you had a good time. And hopefully we'll see you again soon. We'll be planning more sessions in the future, so pay attention to our Twitter account. We usually make announcements through there. If you want to give a session with us, or if you want something, if you have something that you want to share, feel free to get in touch with us, and we'll coordinate everything. For now, nothing else but to thank you all for your time, and hoping that you all stay safe. Have a good weekend, everyone. It's good to see you all.